I'd like to look at integrals involving the chain rule right now. Your book is going to call this derivatives by substitution, or integrals, excuse me, by substitution. But as I indicated in class, I have a far different way that I do these than the book does. If you want the traditional way of solving problems involving the chain rule, you can certainly use the book's method of substitution. But I would advise you, if you've never seen this before and you're not already a big fan of the substitution, to take a look at my method. I find it much more simple. Frankly, when I was first shown the substitution rule back in 1976, I looked at that and said to myself, gee, why can't you just do it this way? And this way is what I'm about to show you, which I thought was far easier than what my professor was trying to show me, again, some 36 years ago. Let's go ahead and take a look at this. Now, this is more or less the very first problem, or one of the first problems that I gave you in class. Let's go ahead and see if we can integrate 3x times the quantity x squared plus 5 to the fourth. Now, first of all, I'm going to go ahead and pull that 3/2 out. You can always take that constant and just move it off to the side and ignore it. So I'm basically going to take that 3/2, ignore it, and just concentrate on the rest of the function. Okay? The next thing I hope that you're going to notice is that what is here on the outside is frankly just the derivative of what's on the inside. This is set up for the chain rule. So more or less, I know that the derivative of what's inside is 2x. Out here I have an x. I don't worry about the 2. I'm going to fix the coefficient later. And we're just going to concentrate on looking at just this function to the fourth power. Again, I know that that x will just magically appear when I take the derivative of what's inside. So let's just take the derivative, or concentrate, if you will, on just this x squared plus 5 to the fourth power. I know again that x is just magically going to appear. Now, our basic power rule says that you raise this power by 1. And that's exactly what I want you to do now. If you recall in class, someone also suggested properly that you could go ahead and simultaneously go ahead and divide by 5. Where you can do that, I really strongly advise that you not consider doing that. Let's just do this as written. Don't worry about the dividing by 5. Just worry about applying the part of the power rule which says you increase the power by 1. Again, we're going to fix that coefficient anyway. So when you're multiplying or dividing by a 5, that'll take care of itself later. Let's just don't worry about that part right now. Again, in applying the power rule, the only part I'm going to worry about is raising that by 1. And don't forget, I still have that 3/2 on the outside there. So let's assume that this really was the answer. Let's assume that when I took the derivative of this, I would get exactly what I was trying to take the integral of. If that's the case, then I'm all done. But usually there is an adjustment that we have to make at the end. So let's see what happens. Again, I'm just going to take the derivative of my x squared plus 5 to the fifth. In doing that, when I take the derivative, I of course move the 5 down in front, lower the power by 1, and multiply by the derivative of what's inside. If I simplify this a little bit, then what I get is 10x times this quantity to the fourth power. Now remember, in my ideal world, what this is going to equal is this guy right here. It didn't quite match up perfectly. The problem is I've got this 10 on the outside, and by the way, if you're not already aware of it, all I did was copy down the thing I was trying to integrate. I've got that 10 on the outside that I've got to get rid of. Now, you've got a couple choices here. Personally, what I always like to do is simply say, hey, let's just take that guy right there and divide by 10. And I'm done. The other thing you could do to get rid of that 10, however, would be to multiply by a 1/10. And then the 10 and the 10 on the denominator, or the 1/10, would also cancel and leave me with exactly what I had to begin with. So what I've got missing is that 1/10. So basically, I'm going to put it in my answer. What I wanted, was exactly what I had before, but again, either I wanted to divide by 10 or I want a 1/10 out in the front. In other words, if I separate this into two separate problems, either I've got that 3/2 times my x squared plus 5 to the 5th divided by 10, sorry about that, or my 3/2 times the 1/10 times that quantity. And now all I have to do is simplify this. Unfortunately, to be frank, there's not a lot of simplification that can take place here. If this 3 canceled with either the 2 or the 10, there'd be something to do, but frankly, there's really not. So if I'm leaving the problem in this form, it would be 3 times the quantity over 2 times 10 is 20. And don't forget, you always have to tack on your plus c, plus your constant. Or, and again, I think this is the way most students would prefer to work it, 3 times 1 is 3 over 2 times 10 is 20. Just to sum up here real quickly, the only thing that didn't work was at the very end where I had to make an adjustment in my coefficient. So what I wanted to do was to get rid of the 10, so I knew I had to divide by 10, or multiply by 1/10, which meant either that times the 1/10 or the divided by 10 needed to be there in the first place, so it'd be there when I needed it at the very end. And again, depending on which version you prefer, these would be your answer. Now, let's check our answer. Let's go ahead and take this guy, which again, I think the one most students prefer. Take the derivative and make sure that I really do get that very initial answer that I had to begin with. Once again, if I want to find the derivative of what I had up here, and by the way, I went ahead and took off the c because the derivative of the constant will just be 0 anyway. I want to find the derivative of what I had. I think the best thing to do would be to take that 3/20 off to the side and ignore it just as we did when we were doing the integration. And again, when I take the derivative of this guy, I move the 5 down in front. X squared plus 5 is now to the 4th power times the derivative of what's inside, which should be 2x. Now, let's go ahead and play some cancellation games here. This 5 would cancel with my 20 and leave a 4. My 2 would cancel with the 4 and leave me with a 2. So quite frankly, what I have now is 3 over 2, or 3/2, times my x times my quantity to the 4th power, which of course matches with the very initial problem that I was given in the very beginning. So I now know that that is indeed the correct answer. Let's take a look at our second example. I want to take the integral of 6x times e to the 5x squared power. Now the first thing I want to do again is pull that 6 off to the side and merely take the integral of the rest of the function. To do that, I want you to first notice again that what is in front is essentially the derivative of what's inside. Now I know there's a coefficient problem, but what I'm really saying is the derivative of this is 10x. I've got the x. I'll take care of the 10 later. At least I need you to see that the x matches up. If the numeric coefficient is different, that's not going to be a problem. This x, again, is the derivative of what's inside, essentially, and it's just going to appear from nowhere. So I'm literally just going to look at taking the integral of just the e to the 5x squared. Well, luckily, the integral of e to the anything is e to the anything. So in this case, the integral of e to the 5x squared is simply e to the 5x squared. And don't forget, we have this 6 sitting outside here. Let's assume that this really was the answer. Let's go ahead and again take the derivative of just the e to the 5x squared and see if it really does give me the original answer that I had. In this case, I've got e to the 5x squared times, don't forget, I need the derivative of what's inside. Let's go ahead and move that 10x out in front and make it look more normal, if you will. What I have is 10x e to the 5x squared. But remember what I wanted? I didn't want all of that. I really only wanted x e to the 5x squared. Once again, I've got that 10 that I don't really want to have there. So let's go ahead and just cancel that out. So what I'm saying is this 1/10 needed to be there in the first place in order to cancel that out. So what I'm going to do is basically insert it into what I thought my original answer was so that it's still there and will then cancel the 10 where I need it to. So what I'm saying this time is essentially this is my answer. Again, I have to multiply by that 6. So I've got 6 times my 1/10 times my e to the 5x squared. This time I do have some simplification I can do. You can think of this, if you prefer, as 6 over 1. But basically what I need to do is cancel. And that more or less becomes 3/5 times e to the 5x squared. And don't forget, you need to tack on that plus c. So let's double check and make sure that this really is the appropriate answer. Let's go ahead and take the derivative of this. Don't forget, the derivative of c is just 0 and goes away anyway. But let's make sure the derivative of what I think is my final answer truly does give me my original function. If I've done it properly, it will. So let's go ahead and take a look at it. Let's find the derivative of my 3/5 e to the 5x squared. First of all, remember, I can take that 3/5 out in front. And then if I take the derivative of my 5x squared, the derivative of e to the anything is that same e to the anything, times the derivative of what's inside, which is indeed my 10x. Once again, there's some simplification I can do here. Let's cancel my 5 with my 10, which leaves me with a 2. And I'll have 2 times 3, or 6x e to the 5x squared, which of course is exactly what I had in my very beginning problem. So I know now for certain that the answer I have, my integral, I did calculate it correctly. Let's do one final example. Let's find the integral of the cosine of the square root of x over the square root of x. Now, you've got a difference on this problem. This is the first one that I have to do a little work with before I even try to integrate it. I don't like those radical x's. You always want x to a power. So the top, of course, will simply be the cosine of x to the 1/2 power. On the bottom, I'll just rewrite that as x to the 1/2 power. Now I'm going to want to take what's here on the bottom, of course, and move it to the top and make the power a negative. So this becomes x to the negative 1/2 times the cosine of x to the positive 1/2. Now once again, I want you to notice that what's sitting out here in front is actually the derivative of what's inside. Once again, I'm just going to worry about just the cosine of x to the 1/2. Remember, this will just magically appear later, and I'll deal with any adjustment in any coefficient at the end of the problem. So, let's talk about the cosine of x to the 1/2. The integral of cosine of x to the 1/2, frankly, is the sine of x to the 1/2. Now, once again, I know you're going to have to do times the derivative of what's inside, so let's check it out and see what happens. In other words, let's assume that this really was the answer. I will take the derivative of this and make sure that it really equals my original function. If it doesn't, then I'm going to have to fix or adjust this. And again, almost always there's an adjustment that I'm going to have to make at the end. It's rare for this to just match up to the original equation that I had. So let's go ahead and take the derivative of the sine of x to the 1/2. And again, how do you take the derivative of the sine? Well, the derivative of the sine, of course, is the cosine of x to the 1/2 times the derivative of what's inside. Now, the derivative of what's inside would be 1/2 times x to the minus 1/2. Now, let's compare this to the original problem that we had, actually. I'm sorry, I moved down too quickly there. This doesn't quite match up. I've got the cosine of x to the 1/2, but instead of a simple x to the negative 1/2, frankly, I have a 1/2 sitting there that I don't want. There's two ways to get rid of it again. Again, I think the easy thing for me to look at this as is I'm just dividing by 1/2, top and bottom, which will cancel that out. I don't think this is the way most students want to look at it though. Again, if you think of it as dividing by 1/2, what I'm actually doing is multiplying by 2. So if I put a 2 out here, this will now cancel with the 2 that I have in the bottom, and these will match up and give me the original function the way they were supposed to. But I can't, again, just put a 2 there because I feel like it. That 2 must have been there all along. So back here, there would be a 2. And I now think that this is my final answer. And of course, I'd have to put a plus c on the end. So let's check it out and see if the derivative of this really does give me my very original function. And don't forget, these two forms that I gave you back here are actually equivalent functions. You can leave it as negative exponents or fractional exponents. I'm going to be fine with that, but keep in mind that in both cases what you really have was the square root of x. Let's go ahead and take a look at this now. When I take the derivative of this function, keep in mind I know the derivative of c is just going to be 0 and go away as always, so I'm not so much worried about that as the derivative of my main answer. So once again, let's take that 2 and kind of set it off to the side here and just take the derivative of sine of x to the 1/2. So putting my 2 out in front, the derivative of the sine of x to the 1/2 is the cosine of x to the 1/2 times the derivative of what's inside. The derivative of what's inside would be 1/2 x to the negative 1/2. And of course, what happens here again? The 2's cancel, just like I wanted. This becomes essentially times 1, which is nothing. Let's go ahead and move this, my power of x, to the front of my function. And essentially what I have now is x to the negative 1/2 times the cosine of x to the 1/2. And regardless of which form you're thinking of, that is indeed the original function that I have. So I have correctly found the integral. And again, just to remind you, I always check my integral at the end, take the derivative, and make sure that I really do have my original function.